Okay, so let's look at an example. A 32-pound weight stretches a spring 2 feet. Determine the amplitude and the period if the weight is released 1 foot above equilibrium position and with an initial velocity of 2 feet per second. Now that velocity, 2 feet per second, would be velocity downward, and lifted up 1 foot above equilibrium position, that would be a -1. So for a mass of weight 32, we get the mass, sorry, for weight of 32, weight is mass times gravity, so 32 equals mass times 32 on Earth anyway, so the mass is 1 slug. The spring constant in f of x equals kx is found since 32 equals k times 2, right? How do we know that? Because that weight displaced the spring 2 feet. So k equals 16. So k over m equals 16 over 1, which is 16. And the differential equation we need to solve is the second derivative plus 16 times y equals 0. With initial condition, y is 0 equals -1, because that was above equilibrium position, so that's negative direction. And y prime is 0 equals -2. Wait, I didn't say that. Initial velocity, I guess that initial velocity is 2 feet per second upwards. Therefore, I can say, all right, upwards, right? Therefore, I can say y prime of 2 is -2. Anyway, the characteristic equation m squared plus 16 equals 0 has roots m equals plus or minus 4i. The solution is of form y equals a cosine of 4t plus b sine of 4t. With these two initial conditions, with this one alone, since sine of 0 is 0, this part vanishes, so we get a times the cosine of 4 times 0, so a times cosine of 0 is -1, so a has to be -1. The initial condition y 0 equals -2 makes y prime, which is -4a sine of 4t plus 4b cosine of 4t, and y prime of 0 equals -2, though that means -2 goes in here, and sine of 0 is 0, so that part goes 0, and sine of 0, or cosine of 0 is 1, so we got 4b equals -2. So b equals, I'm saying -1 here in this thing, but it must be -2. Because if 4b equals -2, then b equals -2.
Ooh, this is fun!